Dear rail lovers, welcome back to Railways Explained. If you follow the work of our channel, you might know that we already spoke about the evolution of Japanese Shinkansen and German ICE trains. Now we'll discuss French TGV. In one of the previous videos, we also spoke about the development of LGVs, where we also mentioned the distinction between LGV, a high-speed line in France, and TGV, which is a French high-speed train that operates on LGV. Right here at the beginning, we will mention that the French infrastructure manager SNCF recently, in October 2021, opened its high-speed network for competition, i.e. it finally liberalized this market segment. In preparation for this step, the TGV Premium in We and the low-cost WeGo service were created to replace the classic TGV services. From October last year, Trenitalia compete with them, serving passengers on the Paris-Lyon-Milan route. SNCF has built its high-speed rail network on three principles. Lines are dedicated for passenger traffic, they are compatible with the conventional railway network, and it should provide high-frequency operation with short journey times. In accordance with this, TGV trains had to be developed in such a way to be interoperable and run on the new LGVs, conventional railway lines, and also on the lines outside the borders of France. Because of this, TGV trains were equipped with multi-system equipment for power supply and signaling. Therefore, all TGV trains are at least bi-current, which means that they can operate at 25 kV 50 Hz AC and 1500 V DC, due to certain conventional lines south of Paris. Also, trains to Germany, Switzerland, Belgium and the Netherlands must accommodate other voltages, requiring the development of three current TGVs. Due to this characteristic, the technical progress offered by the TGV is fully compatible with the former rail infrastructure, and thus investment in an LGV did not diminish the existing railway heritage. Also, these requirements raised development of new technologies and new solutions, which gave the French industry a significant technological edge. High-speed rail technology did not fall out of the sky. It was a result of a close connection between the railway industry, transport research and entrepreneurial flair. As an outcome, the first TGV train, branded as TGV Sud-Est, was introduced in 1980. The first generation of TGV sets was named Sud-Est according to the line that they served. They were also referred to as TGV PSC as an abbreviation of Paris Sud-Est. The first of these trains were built in 1978 by Alstom and Franco-Rail MTE and put into service from 1980 after a period of necessary testing to ensure that the trains were ready for the opening of the line in 1981. When ordering the prototype train, the SNCF wanted to give a strong image of speed and recognizability, so the bright orange underlined by grey became the distinctive color of the SNCF until the mid-1990s. By 1986, a total of 109 train sets had been produced. Each Sud-Est set is made up of 2 power cars and 8 coaches. These coaches have a capacity of 345 seats and have a powered bogie in each of the carriages next to the power cars. The whole train set is 200 meters long. Regarding the speed in commercial service, the TGV Sud-Est trains were originally limited to 260 km per hour, which was then raised to 270 km per hour from the summer of 1982. With the aim of extending the life cycle, these trains underwent 3 renewals. They included upgrading with new equipment and overhauling interior and exterior look. During the second renewal between 1996 and 2001, some trains received a replacement of the bogies, modified gear ratio, improved transformer cooling, and thus their maximum speed was raised to 300 km per hour. The exterior livery was harmonized with the other types of TGV with the colors of metallic grey and blue. During 2011, when some train sets were already 30 years old, a third renewal was done when they received carmelian livery and a new interior layout. The other trains have been gradually withdrawn from the service since 2012 and recycled. The remaining generations of TGV trains had metallic grey and blue Atlantic livery, and gradually got carmelian livers as well. The TGVs Sud-Est are divided in 2 categories, depending on their power supply capability: dual voltage or so-called bi-current, and 3 voltage or so-called 3-current, which allow operation in Switzerland. The first wave of cancellations of these trains that underwent the third renewal occurred at the end of 2018 and the beginning of 2019, following the total withdrawal during 2021. The second generation of TGV trains, TGV Atlantic, were built for the opening of the line LGV Atlantic. This generation, as well as all other that came later, was a product of the French company Alstom. In the period from 1988 to 1992, a total of 105 train sets were produced. The second generation of TGVs has a larger capacity than the first generation, bearing in mind that it is made up of 2 power cars and 10 coaches with a total of 485 seats. They are 237.5 meters long and multiple unit coupling is only allowed between them. TGV Atlantic can reach a maximum speed of 300 km per hour. All train sets were produced as by current with power systems of 1500 volts DC and 25 kV 50 Hz. During testing, SNCF was focused on achieving target speed by modifying TGV Atlantic in terms of improved aerodynamics, larger wheels, and improved braking that allowed test run speeds of over 500 km per hour. As a culmination of these test programs, new world speed record of 515.3 km per hour was set on 18 May 1990. As a curiosity, the first generation of trains used for high-speed services in Spain was produced by Alstom CAF Consortium, based on the design of TGV Atlantic. The SNCF TGV Réseau were built by Alstom between 1992 and 1996. These TGVs are directly derived from the TGV Atlantic, but with a composition reduced to 8 coaches instead of 10. The designation Réseau, which means network, comes from the fact that they were designed to run on the various high-speed lines at the time open to traffic in France. A few small changes have been made to the TGV Réseau compared to the TGV Atlantic, particularly in terms of coaches. These trains are impervious to pressure waves, unlike the TGV Atlantic, which is to say that, for example, you do not feel pressure variations when entering or exiting a tunnel. A total of 90 sets were produced, 50 by current and 40 sets as 3 current trains. As well as using standard French voltages of 25 kV AC and 1500 volts DC, the 3 current trains also include a 3 kV DC system, so they can operate under the Belgian and Italian 3 kV DC power supply system and run towards Milan and Brussels. Formation with 8 coaches gives a capacity of 377 seats. They have a top speed of 320 km per hour. Also, these are the first trains that are equipped with the ERTMS Level 2 system after the renewal. The last 10 of these 3 current units operates under Thalys, a French-Belgian high-speed train operator, and its livery also known as Thalys BPA sets. The life cycle of these trains was extended by their renewals in the period from 2007 to 2008, when bi-current trains were modernized, and from 2007 to 2011, when the same was done with 3 current trains. In 2006, the coaches of 19 sets were used to form TGV POS sets by using new TGV POS motor cars for services on the LGV Est to Germany and Switzerland. The 38 replaced Réseau motor cars were slightly modified and joined to the new duplex coaches, forming 19 TGV Réseau duplex units, but we'll talk about that in a moment. Currently in the operation are 26 bi-current trains, 27 3-current operated by SNCF, and 10 operated by Thalys. The first generation of Korean high-speed trains are in fact the transfer technology based on this TGV train that happened, as we explained in the video on the development of HSR technology in Korea. If you have not watched that video, we recommend you do it. Due to the increase in demand on certain routes, especially those to southeast leading to the Mediterranean coast and winter peaks for skiing, SNCF has started thinking about ways to increase capacity, and several options were on the table. The separation between trains was reduced to 3 minutes on some TGV lines, but the increasingly complex signaling system and high-performance brakes required limited this option. Another option was to widen the trains, but this is generally not practicable due to the loading gauge restrictions. Running 2 train sets coupled together in multiple unit configuration provides some extra capacity, but requires very long station platforms. Given length and width restrictions, the remaining option was to adopt a bi-level configuration or make double-decker trains, adding 45% more passenger capacity. After discussion and cooperation with Alstom, design of TGV duplex was created. The design of these trains has been very advanced, particularly in the field of weight reduction, by the use of aluminium instead of steel for the structure of bodies, except the power cars, in order to respect the rule of 17 tons per axle load on French high-speed lines. Duplex trains have for the same length a higher transport capacity of 133 seats than that of the TGV Réseau. In trains that have the first and second class there are 510 seats, while for example in the WeGo layout there is only the second class with 634 seats. Trains can reach a maximum speed of 320 km per hour. The first train sets were delivered between 1995 and 1998, just after their development by Alstom. Within the duplex trains there are also Réseau Duplex and AC. The Réseau Duplex version, as we pointed out, came into existence when the coaches of 19 Réseau sets were used to create POS sets. The 38 Réseau power cars of these sets, with some aerodynamic adjustments, joined the new 19 sets of 8 duplex coaches S3 current version for destinations in Germany and Switzerland. They were the first of intercoupled series TGV to achieve a sustainable basis by SNCF. The C is an abbreviation for Duplex Asynchronous ERTMS. This series has a similar design to the classic duplex series with internal changes. They feature a new power car equipped with ERTMS and powered by asynchronous motors. These trains were planned to strengthen the connections to the south, including the LGV Perpignan-Figueres, allowing a joint French-Spanish train operation. In the period from 1995 to 2012, 89 duplex train sets and 52 DC train sets were produced, and 19 Réseau duplex train sets were formed. The TGV POS, where POS stands for Paris, Ostfrankreich, Süddeutschland, is a 3-current TGV produced for the opening of the LGV Est in order to provide services beyond Strasbourg to Germany and Switzerland. TGV POS was put into operation in 2007. Unlike previous generations, the SNCF did not completely put this generation of trains into service. As we have already mentioned, 19 TGV POS are in fact the assembly of 38 new 3-current motor cars suitable for driving in Germany and Switzerland, and 19 sets of the existing TGV Réseau type coaches. These coaches were renovated with the installation of a pair of electromagnetic pads for emergency braking requested by regulation in Germany. In addition to the fact that they are 3-current, they are also equipped with asynchronous motors and multi-signaling on-board equipment. KVB and TVM used in France, PZB and LZB used in Germany, SUB used in Switzerland, and ERTMS Level 2. The fleet of 19 trains was initially shared between 2 operators, SNCF, which used 18 trains, and SBB, which used remaining 1. During 2011, it was decided by the 2 companies to offer greater management autonomy to their joint subsidiary called Lydia. For this purpose, the transfer of the fleet was particularly planned in order to make Lyria the owner of the trains, switch a situation with Thalys and Eurostar, and thus make this company much less dependent on the rental of trains. In 2012, the entire fleet of TGV POS train sets were operated under the TGV Lyria, with services between France and Switzerland replacing the 9 TGV Sud-Est train sets that were taken out of service. After 2019, all trains were returned to SNCF and they operate strictly domestic services from Paris Nord and Paris Est, replacing the last TGV Sud-Est. In 2019, Lyria started to renew its rolling stock by procuring specially coated Euro Duplex, which represents a new train sets produced by Alstom. The TGV 2M2, also known as Euro Duplex, is a part of the Alstom Avelia family. We have already mentioned Euro Duplex trains in the video about the construction of a high-speed line in Morocco, bearing in mind that the Moroccan railways ordered exactly these trains to serve on the line. Of course, if you want to find out more about this awesome 320 km per hour rail line in Morocco, check that video out. These double-decker trains represent the 3rd generation of duplex trains after TGV DC and classic TGV Duplex. The first trains came out of production in 2011 when they entered commercial service. To date, a total of 123 train sets have been produced and put into use, and 134 train sets are under production. Like most other TGV sets, it consists of 2 power cars and 8 coaches for a speed of 320 km per hour. Also, Euroduplex is the only double-decker train in the world running above 300 km per hour. The Euroduplex trains are an evolution of the TGV-DAC and therefore incorporate their main characteristics. The engines are of the TGV POS type and include traction chain with asynchronous motorization and with European Signaling System (ATCS). Building on the success of the double-decker TGV concept, whose capacity responds to the increase in use and with the aim of developing the fleet of trains that comply with the TSIs, in particular suitable for electrification system used in Switzerland and Germany, the SNCF was interested in procuring new trains in a 3-current version of the TGV duplex. This bearing in mind that there were only 8 3-current TGV Sud-Est trains, which are not very powerful at this voltage, and the 19 POS trains. Trains are equipped with systems in accordance with the planned lines and the countries that they are supposed to serve. So there are 3 UA trains equipped for Germans PZB and LZB and Swiss SUB signaling systems and 3-current system. These trains are also suitable for Luxembourg since the change of service in December 2016 with installation of ERTMS on the line from Thionville to Luxembourg. In addition, there are 3 UH train sets that are planned for traffic between Spain and France, so they are also equipped with the ASFA signal system, which is used in addition to ERTMS in Spain. Since May 2021, the TGV 2 and 2 3UH trains have established a service between Madrid and Barcelona via Zaragoza under the Vigo commercial brand, with a specific livery on behalf of the Spanish subsidiary of the SNCF, Vigo España. These trains are adapted for the Spanish market, retaining a first class unlike the French trains and the original seats, but receiving a pink headrest. Because of this, they have lost their authorization to circulate in France. Both 3UF trains intended for domestic traffic in France and 3UFC were produced, where C stands for capacity and which have 556 seats or 46 more than 3UF. We were definitely not aware that there were so many variations of the TGVs, but we hope that we managed to give you a good presentation. SNCF has really managed to adapt its offer to new circumstances over time and to constantly meet market demands. Hopefully we didn't miss something, as it was not an easy task to pack all this information into one video. If we missed something, feel free to tell us in the comments. This was a story about the development of TGV trains on Railways Explained. We hope you enjoyed and learned something new about the railways of the world. Don't forget to like this video, share it with your rail-loving friends, and of course subscribe to our channel. To help our production, consider becoming our patron. Until the next time, goodbye.